6, lesson 6. All right, so periodic functions. So we're talking about graphing primary trig functions today, okay? And periodic function, what that means is that, as you guys know, when you go around the unit circle, all the way around, that's one complete turn, and then it starts over again, right? So if you were to graph a sine graph, it's continuous as long as it's not restricted between 0 and 2 pi. So once you go past 2 pi, it begins that pattern again, right? And so what that's called is, it's a periodic function, a function whose graph repeats regularly over some interval of the domain. So sine and cosine graphs repeat regularly because they keep going up and down, changing positive, negative, and coming back to where they started at 2 pi or 0 when you come all the way around. Okay, so that would be their period in this case. Okay, the amplitude of periodic function is defined by half the distance between the max and the min. Okay, essentially what that's going to be is that's going to be the height. Because, for example, our amplitude of a regular sine and cosine graph is 1. Because think about halfway. What it's talking about, and we're getting ahead of ourselves a little bit here, but I'm trying to explain with the context where we're going. But you have sine starts at 0, so sine goes like this. That's what sine looks like. So what's that value for y, do you know? 1, yeah, that's the highest, right? And then what's this value? And so the distance between them is 2. Half of that's 1, so their amplitude's 1. I just think about it, if it's centered at the x-axis, it's just the max point. But the point is that it goes from 1 to -1, that distance is 2. So half that is the amplitude, which is 1. Exactly, yes. Exactly, and I said in this case, you can think about it as the highest point. When it's at the x-axis, if we don't move it at all, then it's just going to be that distance, because they're going to be mirrored here every time. But the length is what we're looking for. Yes, the halfway point is at 0, but that distance is 0 to 1. So yes, good questions. Okay, but anyway, so that's amplitude and periodic. So let's look at these here. So to determine the period and the amplitude of each of the following functions. So when does it start to repeat what it was doing? Okay, when does it start to repeat what it's doing? So we're looking for the period first. So it starts at 0, goes up, down, comes back to 0. So this right here is the period, because it starts the exact same thing again. See, these starts the exact same pattern again. So my period for A is 8. Okay, to actually use the amplitude formula, what they do is you do the top. So 10 minus a -10, because -10 is the lowest, divided by 2. So amplitude is 10. Part B here is going to be a little different in terms of amplitude, because you see part A is symmetric about the x-axis, right? Part B, it isn't now. So our amplitude is going to be a little bit different. Okay, our amplitude is going to be a little bit different. Okay? All right, so this one here, for B, what do you think the period is there? 6. So let's see here. Okay, it is 6. Good try with 7 because of the fold here. But 6 is right on top of that low point there, and 0 is right on top of this low point here. See that? That's where it repeats. So it is 6. Okay, you can start at -1 if you want. That's fine. So -1 repeats at 5. So -1 to 5 is still 6. So whichever is fine. Yeah. Absolutely, distance between them. Yeah, got to count the negative distance. Yep. That's why I went from 0, because 0 stays positive. I don't get confused. Right. Okay, so does that make sense? So the period there is 6. Okay. 1 to 7. Yep, you could go 1 to 7 if you wanted. Just 7 minus 1. Yep. Okay, what is the amplitude? Okay, so 6 is the high point, negative 2 is the low point. So its amplitude is 6 minus a negative 2 over 2, 4. 4 is the amplitude. And so what can help you with that is, and you can kind of see, is that if I go up 1, 2, 3, 4 units, I draw a dotted line, that's cutting it in half. That's cutting it in half, right? 1, 2, 3, 4. 1, 2, 3, 4. Whoops, I missed. I counted one too many, but you get it. It's 4 bottom, 4 top. Okay? All right, let's look at example C. Okay, little weird figures here. So C, what is the period? 10, good. I like to look at 0 myself. So right here is 0. When does that happen again? It happens right here, 10. Okay, so the period's 10. Okay. What is the amplitude? Good. So it's 6 minus 2 over 2. 4 over 2 is 2. So your amplitude is 2. So 6 is the height, 2 is the lowest. Amplitude is 6 minus 2 divided by 2. Okay. Everybody good? All right, so let's get the actual trig functions here a bit. So in this lesson, we'll learn the graphs of sin x, cos x, and tan x. To investigate the graphs of them, we're going to stay within the values of the domains of 0 to 360. To complete, we'll develop the graph of y equals sin x in this class lesson. The graph of y equals cosine x and tan x will be assignment questions. Okay, so we are going to explore sine. Okay, so we're going to explore sine and develop sine. It's going to have you do this for sine or for cosine and tangent. You need to do that in your practice. Don't skip those ones because that helps you get those curves down. Okay, so what's the value of sine at 0? So this is just we're just going through what we just did in the warm-up. Nope, sine. Sine's y. 0. Sine at 0, 0, because there's no y value, right? You haven't moved up or down yet. 30, it's slightly moved up. It's the 1/2. It's the root 2 over 2. It's the root 3 over 2. Nope, that skipped one on me, didn't we? It's not doing the 45, sorry. So, sorry, root 3 over 2 is the 60. Then we're at 1 here for 90. Then it's still root 3 over 2. 150 is the 1/2, and then 180 is back to 0. 210 is negative 1/2. 240, negative root 3 over 2. 270, negative 1. 300 is the negative root 3 over 2. 330 is the negative 1/2. And 360 is back to 0. So there's your coordinates for your sine graph. Okay, we're going to start at 0, and we'll go over to the right, and then we'll just mirror it to the left doing the negatives. Okay, but we know roughly, I kind of use the 90 spots as kind of my key spots, but we got that right there. We got that right there. Negative 1's a little bit lower, isn't it? 2, 3, 4. It's like, it's right there. And it's right there. So this is what the sine curve is going to look like. Okay, that's one period of the sine curve. So growing up to 1 at 90 degrees, growing down to negative 1 at 270 degrees, coming back to 0 at 360. Oh, sorry, it says do not join the points. But okay, go ahead and in your calculator, graph the y of sine x. Okay, do y of sine x. Make sure you're in degree mode because we're doing degrees right now. Okay, and I'm going to pause it for a second and get the calculator up for us. Okay, so when you put in your calculator, you should get it to look something like so. Okay, so that's what it should look like. You have to be in degree mode. You have to change your window to what the book told you to change the window to. So a lot of changes here. We're now in degree mode, so we have to change our stuff to degrees. We're going by 30-degree slices, okay, which is good. Okay, it says on the grid, copy the graph that you see all the way through. So we're just pretty much copying this picture onto our picture now. So you can just finish the sketch that we already started. So we can go ahead and do that now. Okay, so we know we are here. There. Okay, so your curve. Okay, so roughly what your curve looks like. So the regular graph of sin x without restrictions goes infinitely. Okay, it goes infinitely. We don't have any restrictions on it, so it's a continuous graph. Okay, the graph shown in B is a partial graph of y equals sin x. So the part we did to start, that was a partial graph of it. With restricted to, we said we were saying between 0 and 360. So that we took that period of it, which is one period. Okay, but as you can see, it starts to repeat. So here's a starting point. That's a starting point. And then that's a starting point. So we have 3 periods within this range. Well, close to, actually 2.5. Okay, 2.5. Okay. All right, so let's look at this example here. So state the following for the function y equals sine of x, where x is defined on a set of real numbers and expressed in degrees. What's the domain? XER, right? There's no restriction on x. We don't have any problems, so XER. Okay, what's the range? Yep, from -1 to 1. Okay. Amplitude, 1. Period. $360, right? Because every 360 is when it repeats. Okay. And what's our x-intercepts? Right, so it's going to be 0, 180, 360, etc. And so what they're going to say is it's essentially going to be 180. It's every 180. So they put 180n. So every 180, there's going to be a 0, either direction. And that's the NEI thing. N is your integers. Okay. And the y-intercepts. Good. 0. Sine starts at 0. Okay. Good. All right. Last little piece here. Okay, so a student was asked to reproduce the graph in exploration B in radian mode. Write down the graph calc window that they should use. So you're doing radian mode, so what should you use? Like changing what we just had to what they did for degrees. So essentially we're taking those degrees and putting them in radians. So we went, what was our window? Our window was, okay, our window was -360. So what's -360 in radians? -2 pi, good. So -2 pi. What is our, then we went to 540. So 540 is what in radians? 3 pi, good. I see some of you guys doing it right, good. And then what's our scale going to be if it was 30? What's 30 in radians? Pi over 6. So there's your radian window range. There's your radian window range. 30 degrees. Yeah, pi over 6 is 30 degrees. Now, your y stays the same because those are values. That doesn't change. Okay, so we still stay with the -1.2, 1.2, scale of 0.2. 3 pi is 540. 3 pi is 5. Okay? And so it's a sketch the graph now, and you're doing it with 0 to 2 pi for sine. So you're doing it in radians now. So we're just going to sketch this in radians. Okay, so we're going to go pi over 2, 3 pi over 2, 2 pi is kind of how I think about it. Oh, wait, I skipped one. I skipped pi. Pi over 2, pi, 3 pi over 2, 2 pi. There we go. Okay. Yeah, no, what I put on there is every 90. The 9, so like those even numbers, right? So sine starts here. At pi over 2, it's at 1. At pi, it's at 0. At 3 pi over 2, it's at -1. And at 2 pi, it's back to 0. So we can kind of see here that this is the radian periodic graph. And so there's your sine curve there. Okay? All right, so that's all for lesson 6.